Okay, for this video, we'll be going through our Temasek Secondary School paper, final term exam 2022, paper 1. Okay, so although this question paper that we uploaded says that there are 30 questions, but because some of the questions are not really in our syllabus, okay, for this year, so you'll only be seeing 21 questions, right? Okay, so the first question, which of these is a vector quantity? So first of all, you need to know what are vectors. So they actually have directions and magnitude. They have direction and magnitude. Okay, then for scalar, it only has magnitude. Alright. So for this question, they're asking for the physical quantity that actually has direction and magnitude. So the first one is mass. Mass is actually a scalar. Moment is actually a vector, because if you recall, it's either a clockwise or anti-clockwise moment. Power is a scalar, and work done is also scalar. Okay, so other things that you might need to take note are pressure, which is scalar. We have velocity, which is a vector. We have speed, which is scalar. Then we have distance. We have time. These two are scalar as well. So for the vector part of distance, it is displacement. Displacement is a vector. So all this you need to memorize. Acceleration is also a vector. Okay, so for this the answer is B. Now, which of following represents the shortest length? So I'm looking for the shortest length. So this question, they're actually testing us about prefixes. Okay, so for prefix, you need to actually memorize and also need to know how to manipulate. Okay, so for prefixes, we have, just a second. We have 10 to the power of 3, which is kilo. 10 to the power of 6 is mega. Okay, and you also need to know their symbol. Mega is capital M, kilo is small letter k, then we have 10 to the power of 9, which is giga. Giga is capital letter G. Then now we have 10 to the power of 12, which is tera, which is capital T. So these are sort of positive indices, right? Then we also have the negative one. That means they are getting smaller and smaller. So 10 to the power of minus 3 is actually milli. We have 10 to the power of minus 6, your micro. Okay, so again, you need to know their symbols. M is small, milli is a small letter M, micro is a U with a pigtail, something like that. Then we have 10 to the power of minus 9, which is nano. So small letter n. Then we have, okay. So other than memorizing what the prefixes means, what is their value, you need to be able to convert, okay, from whether prefix to no prefix. So since I saw this, centi is actually 10 to the power of minus 2. Okay, centi. Then we have deci, 10 to the power of minus 1. Okay, so these are the prefixes that you need to know. Okay, and they are fixed before the unit. That's why they are called prefixes. Okay, so as I was saying, you need to be able to manipulate. That means from having prefix to no prefix, okay, we multiply by the value of the prefix. Okay, so firstly, you need to memorize what is the value of the prefix. Then you look at the question. If you are going to have from prefix to no prefix in the unit, we need to multiply by the value of the prefix. I'm going to use 10 to the power of minus 4 mega meter. So mega meter actually has prefix. Okay, and to make a fair comparison, I need to make everything to the common unit of meters. So I am actually going to convert from megameter to meter. I'm going to convert it from prefix having a prefix to no prefix. So I'm going to multiply by the value of the prefix. So I have 10 to the power minus 4 megameter, right? I need to multiply by the value of the prefix, which is actually mega, which is 10 to the power of 6. Then it will be 10 to the power of 2 meter. So you see, at first we started off with having a prefix of mega meters. Now we convert it to just having meter. We get this value of 10 to the power of 2. Okay, let me do one more example. For B is 10 to the power of 3 kilometers. I'm going to convert from kilometers to meters, from having prefix in a unit to no prefix. So I need to multiply by the value of the prefix. So, sorry, very messy. 10 to the power of 3, I multiply by the value of the prefix, which is 10 to the power of 3 as well. So I will get 10 to the power of 6 meters. My prefix is gone. I'm just left with the unit, right? Because I multiplied by the value of the prefix. So for C, it is 10 to the power of minus 5 cm, right? So I take this value of 10 to the power of minus 5, I multiply by the value of the prefix, which is 10 to the power of minus 2, because it is centi. So I'll get 10 to the power of minus 7 meters. So this is C. How about for D? It is 10 to the power of 7 micrometers. So I take the value, I multiply by the, I take the number, I multiply by the value of the prefix, which is 10 to the power of minus 6. So I'll get 10 to the power of 1 meters. Therefore, the correct answer is C, because we are looking for the smallest value. And I convert everything to the common unit of meters. That means all of them don't actually have a prefix. Then I can make a fair comparison. So to do well for this question, you need to memorize all these values. Okay, and you need to know from prefix to no prefix, we multiply by the value of prefix. But what if it's from no prefix to having a prefix? Then we divide by the value of the prefix. Okay. Okay, so for question 3, it was taken out because it's not in our syllabus. So question 4, let's read on. When a beam of light is incident on a surface, okay, it delivers energy to the surface. The intensity of the beam is defined as the energy delivered per unit area per unit time. Okay, so what is per means? What does per means? Per is actually means divide. Like you work in McDonald's, right? You earn a wage of maybe $2 per hour. Okay, so every hour you earn $2. $2 per hour. You take the dollar, you take the money, you divide by the time. Okay, so now intensity of the beam, let's call it I. Okay, it's not actually in our syllabus, but it is the energy, which is E, delivered per unit area over A per unit time. So the intensity of the beam is actually E over A T, which is area multiplied by time. Alright, but they want it in SI base unit. SI base unit, right? So what is energy's unit? Energy's unit, as you know, it is joules. Okay, and how do we get energy? Energy is equals to force times distance moved in the direction of the force, or we can use half mv squared, which is kinetic energy, or we can use mgh. Okay, so will we all arrive at the same unit? Let's see. I'm going to use this to teach you all this force times distance, half mv squared and mgh. Okay, force is, what is the unit for force? It's actually newtons, right? I'm going to write the units here in brackets. The SI unit for distance is meters. So for SI unit for mass is actually kg. The SI unit for velocity is actually meter per second square, right? So this is the SI unit. The SI unit for mass is kg. The SI unit for gravitational field strength is Newton per kg. And SI unit for this is actually meters. Okay, so maybe you work with F times D first. is actually Newton multiplied by meters in terms of the units. But what is Newton a base unit? It is not, right? Now, how do we get force? Force is actually equals to MA, right? You learn F net equals to MA. So this is Newton. This is actually kg. The SI unit for acceleration is meter per second square. So I can actually convert my Newton into kg times meter per second square times meters. Okay, so is kg a base unit? Yes. Is meters a base unit? Yes. Seconds also. Meters is also. So this will give us a combined unit of kg, meter square, s square. Okay, and take note, this is quite difficult because we are still at E. We are just finding what is E in terms of basic, in terms of SI base unit. Okay, but I'm just going to stop here for energy in terms of force times distance. Let's look at half mv square. Okay, let's look at half mv square. So half mv square, it is this. Okay, half doesn't have a unit, but the SI unit for mass is kg. Okay, multiplied by meter per second whole thing square. And when I expand it, doesn't it become kg meter square over s square? So these two are actually similar. It has to be, because work done or energy is force times distance moved in the direction of force. You can also get energy if it's in the kinetic store, half mv square. You can also get energy in your gravitational potential store, which is mgh. So by right, all of them should yield the same unit. How about mgh then? Let's look at it. mgh, the units are, let's use a different color. mgh, I have kg, right? I have kg multiplied by Newton per kg multiplied by meters. So you see that kg and kg can cancel out. So I'm left with Newton multiplied by meters. And Newton multiplied by meters will also in the end give me kg meter square over s square. So I'm not going to do this, right? Because it's already proven in your Newton times meter. So as you can see, all three formulas actually gives rise to the same unit. Although we use different quantities, but in the end they still give rise to the same unit of joules, which in terms of base unit is kg meter square s square. Alright, so far. So we are only halfway done because what we done is for E. So E, I can safely write it as kg meter square s square. Okay, so this whole thing is going to be divided by area and time. Okay, so we are coming to the solution already. Please continue to follow. Area is actually SI unit of meter square. SI base unit for time is seconds. Okay, so now you have to do some form of math manipulation. So I have kg meter square s square is divided by m square s square. That means it is going to be multiplied by m square over s. Okay, let me do my math. Okay, my math also not that good. So maybe I rewrite it as divided by m square s. Okay, because this line tells me it's divide. So kg m square s square is divided by m square s. Okay, so I get kg m square s square multiplied by 1 m square s. So my m square and m square can cancel. My s and s square can be multiplied together because they are in the denominator. So in the end, I get kg over s cubed. Okay, let's see if there's any answers corresponding to this. Kg over s cubed. Okay, we have answer D. Okay, so D is the answer for question 4. So how is kg s to the power minus 3 equals to kg s cubed? Because this was the answer that I got it, right? Because for your negative, this is your math, for your negative indices. For negative indices, it just means that it is 1 over. So it is kg, okay, over s cubed, right? This is your negative index. So question 4, answer is D. Okay, coming to question 5 is a ticker tape timer. I don't know whether your teacher has shown it to you. Okay, it actually puts 30 dots on a piece of paper tape every second. That means in 1 second, it will make 30 dots. Which means if I want to make 1 dot, I will need 1 over 30 seconds. So this is what it means. Okay. So 1 over 30 is not going to be a pretty number if I multiply or divide it by. So I just leave it in fractions for now. Okay. And for ticker tape timer, a very important thing that you need to take note is count the gaps. Count the gaps. Because initially for ticker tape timer, let's say I have a piece of paper. This is the ticker tape timer. It actually makes a dot at the initial point. So the first dot is already there no matter what. It's only when the motion starts moving, when the tape starts moving, excuse me, then it will continuously make dots. Okay, so these dots are actually made by the ticker tape timer. And the first dot we don't count, right? Because it was already there. Therefore, I will need you all to count the gaps. Alright, so from X to Y, how many gaps are there? 1, 2, 3, 4, 5, 6, 7. From X to Y, there are actually 7 gaps. There are 7 gaps. How long does it take to make from one dot to the other? It's actually 1 over 30 seconds. So in order to make this, I have 7 gaps. So I will take 7 multiplied by 1 over 30. So I get 7 over 30 and the answer will be, so the answer will be 0.23 seconds. So it's either point A or B. Okay, now we need to find out how was the motion. Okay, they want us to describe the motion of the object as it moves from X to Z. That means at the start here, I have this dot. Okay, let's say I have a car, a toy car pulling this tape. It's going to travel from X all the way to Z. Therefore, this first dot that was already made by the ticker tape timer before we started all this is this dot. So this is actually the first dot that was made. And when the question mentioned X, this is actually sort of the last dot. Okay, so this is first dot. You need to know because it moves from X to Z. The toy car will move all the way. It will drag the tape with it until here, and it will have a lot of dots behind it. And this is the first dot. So as you can see, the dots are made at a constant frequency, right? That means every 1 second they'll make 30 dots, or every 1 dot or the gap between the dots, it will take 1 over 30 seconds. So all these time intervals are the same time interval of 1 over 30 seconds. But do you see that actually the gaps at first was large? In the end, the gaps are smaller. So from large gap to become smaller gap, it is actually decreasing in speed, right? Because given the same time frame, if I ask you to make a larger gap, you will have to move at a higher speed. Okay, so answer for this question is B. Okay, question 6 is a VT graph. So what is important about VT graph? Two things. For VT graph, gradient represents acceleration, and the area under graph represents distance traveled. Okay, so the story is that the ball is being launched vertically upwards. So at time equals to 0, it is launched upwards, and you see that it has a positive velocity of 22. That means going up is taken as positive. Okay, then over here we have negative velocity. That means it has changed direction. When did it change direction? It must change direction when the velocity equals to 0. That means at this point in time, the ball has reached its maximum height. Okay, and air resistance is taken to be negligible. And since this is on Earth, the gravitational field strength or gravitational acceleration is taken as 10 meter per second square. So they want us to find out what's the acceleration of a ball when velocity v equals to 0. It happens at this time here. Okay, so they want us to find out the acceleration. So as you can see, for VT graph, the gradient represents acceleration. Alright, and the gradient over here is actually negative gradient. The value is 10 meter per second square. So answer will be A, negative 10 meter per second square. So you may think, why is it negative? Because acceleration due to Earth is always downwards, right? Gravity pulls things down. And for this question, upwards is taken as positive, right? I've talked about this, right? For this question, it is launched upwards and we have a positive value. So downwards is negative value, and acceleration pulls us down, right? Gravity pulls us down, so it must be a negative value. So I say again, positive and negative doesn't mean good or bad. It just tells us the direction. Okay. Now, question 7, what's the time t when velocity v equals to negative 36? Okay, so we are going to find this time t. And of course, because there is no air resistance and on Earth is a constant value of 10 meter per second square, we can use these values to do our calculation. So we have a equals to v minus u over t. Okay, and the acceleration is taken to be negative. V, final v is minus 36. Initial is 22. So over t, right? So t will then be equals to minus 58 over minus 10. Therefore, they will work out to be a positive value of 5.8 seconds. Okay, so velocity can be positive or negative, acceleration can be positive or negative, but time can never be negative. You cannot go back in time, right? So the value is 5.8, and this is solved using a equals to v minus u over t, and recognizing that the acceleration is found from the gradient of the graph. Okay. Question 8, an object is projected up a smooth inclined slope with an initial velocity of u. That means it has initial velocity of value u. Okay, which of the following best describes the variation of the displacement s of the object along the slope? So they are asking for the displacement, right, with time. And again, air resistance is taken to be negligible. Smooth, that means it's going to have no friction, right? So because it has to do work against gravity, it cannot be A, right? And displacement is how far it is from its object is from original. Okay, so the displacement cannot be a constant value, right? Because as it's being projected up a slope with an initial velocity, no other forces are acting on it except gravity, which is pulling him down. Okay, so it cannot be a constant value of s. All right, and d is out because at time equals to 0, the displacement should be 0, right? Because this is original position, so the displacement should be 0, right? So it should either be B or C, right? These 2 points are correct. But why is there a variation? Okay. Okay, so I've written here for we are dealing with a displacement time graph, right? And what is important about displacement time graph? The gradient represents velocity, right? So imagine you project this box up, it will not go on infinitely with constant velocity because gravity will be pulling it down, right? So the velocity will actually decreases. And what does gradient represent in a displacement time graph? It represents velocity. So if velocity decreases, that means the gradient decreases. So as you can see here, initially it was pretty steep, right? Then after that, it becomes gentle. So the gradient actually decreases, right? But over here, the gradient remains constant. That means it has constant velocity, because gradient represents velocity in a displacement time graph, and we know that the velocity will not be constant, it will slow down. Therefore, answer will be C. Okay, question 9. Two forces act on an object, but the direction of action of both forces are unknown. One force is 5 Newton and the other force is 8 Newton. Okay, so if you have done your TYS topical, you'll find that this kind of question is very popular. So I can think of actually two extreme scenarios, because they say the direction of action are unknown, right? So the two extreme scenarios are this. This is 5 Newton and this is 8 Newton. Okay, so 5 Newton and 8 Newton, right, if they are in parallel, the resultant force, which is what they want us to find, the F net resultant force, is actually, because they are in the same direction, we can add them together. 5 plus 8 equals to 13 Newtons. So this is the first scenario. So that means I cannot get a value more than 13 Newton. It's just impossible, right? Then the other extreme scenario is I have 8 Newton this way, I have 5 Newton acting in the opposite direction. Okay, it's really the most extreme scenario. So in the end, my F net will then be 3 Newtons. Okay, so this is my lowest limit for F net, this is my highest limit. That means D is possible. Anything between 3 and 13 is possible. That means A is not possible. Okay, don't believe me, you can try any variations, then you can draw your vector diagram. You'll find that 2.9, it is virtually impossible. Okay, question 10, they want us to, they shows a speedboat moving on water, so there are a few forces acting on it. So the force on water due to propeller is 2000 Newton. That means the force is acted on water due to the propeller. Therefore, the water is pushing back with a force of 2000 Newtons, right? Because the propeller push water, water push propeller, and this is our Newton's third law. Okay, so let's draw a free body diagram. It shows all the forces acting on this body. So on the boat, I have 1800 Newtons. I also have a force of 2000 Newtons. How do I get this 2000 Newton and the direction? Because this question wants to mislead us to say that the force on the water due to propeller or the force on boat is 2000 in this direction, but it is not. Okay, read the question carefully. The force on water due to propeller or by propeller. That means third law, we have 2000 Newton acting. This is 2000 Newton of force on propeller, which is attached to the boat by water. So this is Newton's third law. Okay, so the direction is in this direction, must be opposite in direction, must be equal in magnitude. Therefore, I come to draw this free body diagram of 1800 Newton versus 2000 Newton. So I'm sure later on there'll be some option that adds up these two forces wrongly together, because if you are not careful, you'll just draw your free body diagram as this. Okay, if you are not careful, you will just do this, and then you'll get 3800 Newton of F net. This is incorrect. So my F net is actually 200 Newton, because 2000 is more than 1800 and it will be in this direction. Okay, so F net equals to MA. The mass is 100 kg. Please take note, in order to use F net equals to MA, all of this must be in SI unit. So now I can substitute 200 equals to mass of 100 kg. That is okay. Therefore, my acceleration will be 2 meters per second square. So answer is B. I think in my previous video, I always emphasize the importance of free body diagram. Please draw free body diagram acting on that object, which is the boat itself. Okay, question 11, the data shows weight and masses of different objects placed on 4 different planets of different gravitational field strength. However, some of the values may be wrong. Which one show displays that the data is correct. They are looking for correct data. So the formula here is W equals to mg. So this is very tiring. I just put every value inside. So my left hand side must be equals to right hand side in order for it to be true. So you can find the values. If they are correct, like left hand side easy, 9.5, and if 2.5 multiplied by 3.8 I also get 9.5, then this is true. Okay, so you work it out yourself. The answer is C. Please check it out yourself. P and Q are two different cubes with the same weight, so they have the same weight. Yeah, same weight means same mass, because I saw the word inertia. Inertia is the reluctance of a body to change its state of rest or uniform motion. Okay, and it is determined by mass. So if I have the same mass, I have the same inertia. And if they have the same weight, they have the same mass, therefore they have the same inertia. That means A and B are wrong already. Okay, then they because they have same inertia, they are correct. How about density? Density equals to mass over volume. So same mass, same weight, right? So their mass is the same. But Q has a larger, Q's volume is larger, right? Therefore, the density is lower. So Q has a lower density. So answer is D, 12D. Okay. Okay, 13. Isolated disk subjected to 3 forces, each given in terms of units of magnitude F. Okay, I think I didn't mention this at the start of the video. Do you realize that for MCQ, they are arranged in chapter order? Okay, so this is actually your mass and density, right? You have your dynamics, your forces, right? You have your VT graph, which is kinematics, and then you have your chapter 1, which is the units and measurement. Okay, so actually right after your mass and density is your what you call that, moments, right? So this is moments. So they are asking, they are subjected to 3 forces, and the forces are not of equal value. If you see in A, F, 3F and 2F, right? But over here the forces are all the same. They're asking for which disk will experience a resultant force but no resultant moment. So we can take all the pivot to be in the center because we are dealing with moments. So we take pivot to be in the center. Let's look for those that has which one? Okay, A is out already. A is out. Why? Because there is no F net, right? 1F, 2F going in the same direction, so their F net is 3F, and then it's being cancelled out by this 3F, so we don't need to consider A. Okay, then which one? This one will have a resultant moment, a resultant force, so F net is equals to 2F. Okay, but they want no resultant moment, so this, okay, moment is calculated by force multiplied by perpendicular distance. So this is the perpendicular distance, and this one actually passes through the pivot, right? 4F passes through the pivot, so no perpendicular distance. So I have perpendicular distance for this. Okay, so this question is a bit tough, So this one, there's no perpendicular distance, no moment, right? I want a resultant force. Remember, I want F net, but I don't want a moment. I don't want a net moment. So this and this will actually cancel each other out because they have the same perpendicular distance, but the direction is opposite. So they will cancel each other out. So moment, net moment is 0. So answer is actually D, I believe. Okay, so D is the answer, but let's look at C and B. Okay, so will this have a resultant force? It seems like there will be a resultant force because if I were to draw, or like just roughly draw my vector diagram, which is actually my free body diagram. Okay, so this, if I do tip to tail, there is actually a resultant force. So for this, there is a resultant force, yes. But do we have no moment? Okay, so this force is out. right? When it comes to generating moment, because it passes through the pivot, the perpendicular distance is 0. For this, there is a perpendicular distance of this. For this, also perpendicular distance. And if you take this as the pivot, you'll find that there will be a net clockwise moment. Net clockwise moment. But I'm looking for no resultant moment, so B is wrong. Okay, similarly for C, let me try to sketch out the what you call that, the free body diagram, and we see that there is a possibility that there is no Fnet. Okay, there's no Fnet possible, because I'm not actually doing it to scale, no Fnet. But let's see if there's any resultant moment. So again, the perpendicular distance of this force is 0, right? Because it passes through the pivot. But for this is actually this radius, and for this is this radius. So if you were to apply to find my pen trick to find the moment, you'll find that they both generate anti-clockwise moment. So they'll just add up. Therefore, there will be moment. There will be a resultant moment. But the question is asking for no resultant moment. Okay, sorry, this my presentation is a little bit messy due to the space constraint, and so if you don't understand this, please look for a teacher for consultation. Okay, but answer is D. Okay. Question 14, a 20 kg luggage, this is the mass, is placed on a platform which has negligible mass. It is supported by 2 weighing scales. What are the readings on the weighing scale? So this platform is negligible mass. So what are the forces acting on this platform? There is a supporting force here. I call it F1. There's a supporting scale, supporting force on weighing scale 2, right? It supports the platform. So the platform is the object that we are concerned with. The object, and then we also have the force of the let's call it weight. It is the weight that is acting on a platform. So there are actually 3 forces. Okay, there are 3 forces, and guess what? If you add weighing scale 1 and the value of weighing scale 2, it will give me 200 Newton. This will also give me 200 Newton. This also 200 Newton, and this is 400 Newton. So which one is correct? So I can straight away say that D is wrong, because if you look in terms of forces, we are not doing moments yet. If you look in terms of forces, this is the object. I have a force of 200 Newton. How do I get 200 Newton? Because the weight is equals to mg. So it is 20 kg multiplied by 10, so I have 200 Newtons. I have F1 here. Okay, I have F2 here. This thing doesn't collapse. It doesn't collapse, right? That means the F1, the sum of the resultant force of F1 and F2 must be equals to 200 Newton. But now they tell me that total force is 400. So by right, this thing should fly up. But it's not like that. So D straight away is out. Then now we go on to what you call that? Moments. Okay. When we did this, we can straight away cancel out D in terms of forces. But now we have to do by moment. And I know A confirm out lah, because the weighing scale got 2 things. How can weighing scale 1 not have any values? So it's either weighing scale 1 or weighing scale 2. Both must have values. Okay, and I know C is out lah, because they cannot be exactly the same. So answer is B. Okay, but how do I do this question? If I were to not give you in terms of MCQ. Okay, so some of you can just by common sense or by your smartness, you can choose your answer to be B, right? But let's do in terms of moments. Okay, so for moments, we do as a 6-step process. So step 1 is identify pivot. Now there are two supporting points, so there are actually two pivots. Okay, so maybe I choose weighing scale 1 to be the pivot. Okay, so I choose weighing scale 1 to be the pivot. You can also choose weighing scale 2 to be the pivot, but for me, I choose weighing scale 1 to be the pivot. Okay, so then after that, you next step is how many forces are there? How many forces? Okay, I think in my previous video, I also went through these 6 steps. How many forces are there? There's actually F1, there's actually weight of 200 Newton, and there's F2. So 3 forces. Okay, then step 3 is the most difficult, finding the perpendicular distance of each force to pivot. Finding perpendicular distance of each force to pivot. Now, we chose weighing scale 1 to be the pivot over here, and F1 is actually passing through the pivot. So F1, the perpendicular distance is 0. Okay, so for the 200 Newton, the pivot is over here at F1, right? So the perpendicular distance is 3 meters. For F2, the perpendicular distance, using F1 as the pivot, using the position of weighing scale 1 as a pivot, perpendicular distance is 3 plus 2 equals to 5. So actually this step is the most difficult. Okay, you cannot make any mistakes in here. Question 4, calculate what is the moment, force times perpendicular distance. So for the 200 Newton, moment due to the 200 Newton, it is 200 multiplied by 3. So I get 600 Newton meter. So for the moment due to the force 2, it is F2 multiplied by 5. Because the pivot is actually at weighing scale 1, and there's a perpendicular distance of 3 plus 2, 5 meters. So I get 5 F2. Unit is Newton meter. Step 5, direction of the moment. Okay, so for moment of 200 Newton, it is actually clockwise. For moment of F2, it is actually anti-clockwise. Okay, then because it is in equilibrium, I can apply my principle of moment. So I take 600 to equate to 5 F2. So F2 equals to 120 Newton. Okay, so answer is B, 120 Newton. And because the net force is 0, the value on weighing scale 1 must be 80. Okay, so this is for question 14. Okay, question 15. What will happen to the center of gravity of the mug and its content as it is filling up with water? Okay, so initially without water, this is the original CG. Okay, so something like that. Now as I add up more water, as I add in more water, okay, more water will be over here. Yes, then with some water at this base, it will actually move down. This will be the new CG, right? Because now I have some water over here, right? But as I continue filling up with water, so original it went down, but as I fill up more with water, it will become sort of uniform again. So it will move down a little at first before moving up. So answer is A. So question 15 was still about CG, is still about moments. Now we go to question 16. We have a swinging pendulum. At which point is a pendulum having the maximum kinetic energy? So answer will be D. Okay, why? Because if this is the D is actually the lowest height that you can get. B is actually the maximum height. So maximum height, you will equate it to maximum energy in the gravitational potential store. Okay, at C there is still a certain height, same for A. So here we'll have some energy in the gravitational potential store and also in the kinetic store, and similarly for A. But for D being the lowest point, so zero height. Zero height, that means it's going to have maximum kinetic energy, or maximum energy in the kinetic store. So answer is D. Okay, D, yeah. Okay, question 17, an object of mass m passes a point x with velocity v and slides up a frictionless inclined plane and stops at y with height above x as shown in the diagram. So initially at x, what kind of energy does it have? Okay, it will have Ke, energy in kinetic store. At y, because it stopped, it only has energy in a gravitational potential store. Okay, now if another object of the same mass passes point x with velocity 2v, what will be the height that it will rise to? So now we have actually two scenarios. Okay, let's look at the first scenario whereby the mass is m. So initial energy is half mv squared, and due to principle of conservation of energy, we can equate it to the energy that it has at y, which is purely energy in a gravitational potential store. And you see that the mass can actually cancel out. Okay, so the height is actually equals to half v squared. Okay, so I make height the subject of the formula. Okay, so I bring my g over, is 1 over 2g multiplied by v squared. Okay, so this is the first scenario. For the second scenario, it still obeys the principle of conservation of energy, but just that same mass, just that the v is now 2v squared equals to mgh. Okay, so this is the first case. I'm dealing with the second case now. Okay, nothing has changed. The mass has changed, not changed, remains constant. We still have half, we still have the same g, but just that the velocity that it was originally at x has now become 2v. Yes, so we see that the mass and mass can cancel out, and I will have half multiplied by 4v squared, right? I bring in a square and I have my g and my h. Okay, so I try to make h the subject of the formula again. So I have half 1 over 2g, and I bring my v square and I choose out my 4. Okay, so I call this h1, I call this h2. So h1 is actually 1 over 2g v squared. So I can replace this with h1. So do you see that h2 is going to be 4 times h1? So answer will be C. Okay, so this one is very mathematical. Okay, basically I use principle of conservation of energy. I equate these two values. Then I find what is h in terms of the other values, basically your v lah, because your g don't change. Okay, so I have h1, which is the first case scenario's height in terms of its velocity. Then come to scenario 2, whereby the velocity is twice. Nothing else has changed. I try to find the value of h2 in terms of h1, and I through mathematical manipulation I get the value of 4h1. Okay, so again, if you are not very sure about this question, you can check out with your teachers. Okay, for question 18, we are still at work energy power. Okay, so as you know, power equals to energy over time. Okay, so this is the formula that you know, right? Because power is the rate of energy conversion. Yeah, the rate of energy conversion. But energy is also work. Energy is also equals to force times distance over time, right? Where do you get force times distance? Because this is our work done. And for this question, they tell us that it's moving on a level road at a constant speed. That means my V is constant. The engine produces a constant force, so my F is also constant. So if I were to break this up into force times D over T, right? You know your math, F times D over T is actually equals to F times D whole thing over T. Yeah, and D over T, because they tell us it's constant speed, and F over T, D over T is actually V. So I will have this formula, P equals to force times V. And the question specifically mentioned that it is constant speed, constant force. That means for this car, the power is constant. That means across time, no matter how time has changed, the power must be constant. Okay, so it's either A or D, right? And what is power equals to? Power equals to energy over time. So if my power is constant and my time changes, that means my energy must, the rate of change of energy must be constant. And because this is work done per unit time, so answer must be A. Because E over T is like your energy over time, right? The gradient. Okay, so it must be a constant value. How about for D? You find that E over T is actually 0. Okay, there's no, yeah, the gradient is 0. So it is not this, not this. So answer cannot be D. Okay, so answer for this 18 is A. Okay, question 19. Now we go to pressure. Okay, it's divided into two sections by a rock. Section X is longer than section Y, but the two sections are otherwise identical. Water in the lake by the dam is the same depth everywhere. Diagram shows a view from above of the lake and the dam. Okay, the water creates a total force on each section of the dam and an average pressure on each section of the dam. Which statement is correct? Okay, because pressure should be the same. Okay, therefore your answer is A. The average pressure on X equals to average pressure on Y. Okay, so is the total force on X equal the total force on Y? It is not, because X experiences actually a larger force. There are more water that's exerting on this longer section of X, and because pressure equals to force over A, for X the force is larger, but because the area of the area of X is also larger, therefore they must have equal pressure. So the average pressure on X must be equal to the average pressure on Y. Okay, for 20 it shows the brake system of a car. So the force from foot on a brake pedal, force from piston on brake. So the enclosed pipes are filled with incompressible liquid. Yeah, when a force is applied to the brake pedal, the pressure in the liquid increases and applies a force to each of the four wheels. The area of the piston connected to the brake pedal, where is it? Over here is 8 cm square. So you need to identify where this is. The area of each piston connected to the brakes is 12 cm square. A force of 800 newtons is applied by the foot to the brake pedal. What is the total force applied to the brakes? Okay, so for this you need to apply Bernoulli's principle, Pascal's principle, which states that the change in pressure is the same throughout a incompressible liquid. So that means the P at maybe I call this P1 must be equals to P2 or P3 and P4. Okay, so P1 is actually force 1 over area 1 equals to force 2 over area 2. Okay, so F1 is actually 800 over this area of 8 cm square. I'm trying to find what is the force exerted at piston 2, F2. The area is 12 cm square. Okay, so if I were to do my math, then I will get it to be 1200 newtons. Okay, but this is not the final answer, because this is just the force exerted at piston 2. We also have piston 3, P4 and P5. So what is the total force applied to the brakes? Okay, so I will need to multiply by 4 to get 4,800 newtons. Okay, so answer is D. Then come to 21. It shows two mercury barometers. Okay, it's measuring atmospheric pressure on day 1. For barometer 2, measuring atmospheric pressure on day 2. Okay, which statement is true? So this is atmospheric pressure acting, right? And if they are ideal, because they never say that it's non-ideal, so I take it that it is vacuum inside. So atmospheric pressure is dependent on the vertical height. So this is H1, this is H2, and I have P atmospheric pressure acting on day 1 and day 2. Which statement is correct? So how do we find? Okay, let's go through option 1 and option 2 together. The atmospheric pressure on day 1 is less than the atmospheric pressure on day 2. This is not true, right? Because if you see, H1 is equals to H2, right? And P atmospheric pressure is acting on this surface, sorry, my mistake. Actually, H1 is not equals to H2. Okay, H1 is less than H1. Okay, pressure equals to rho GH. Okay, and density is the same, G is the same for both cases, but H1 is actually larger than H2. Therefore, P atmospheric 1 is greater than P atmospheric pressure 2. So let's see, atmospheric pressure on day 1 is less than atmospheric pressure on day 2. This is false. You're right. Atmospheric pressure on day 1 is the same. This is also false, as you can see from here, right? Just now, what mistake did I make? I didn't get the H. I didn't compare properly. Okay, I see that the height H1 and H2 was the same, but actually it is not. Okay. Now, pressure at X, point X is less than the pressure at point Y, versus pressure at point X is the same as pressure at point Y. So at point X and Y, you find that they actually have the same vertical height of mercury above it, So actually the pressure at point X, it is the same as the pressure at point Y, right? Because they have the same height of mercury above it. They have the same height of mercury above it, and pressure is calculated by rho GH. Since we use the same liquid, we have the same G, the height is the same, therefore pressure Px is equals to Py. Alright, so please look through all these questions and the solution, and please let your teacher know if there are any questions that you are not very sure. Okay.